Evening all. I got to hurry up, the sun's going down. Saturday, me and my granddaughter was at the shop and we had the opportunity to test the Magnatech inverter drive CACR-SR 05BE12G-E. That's a mouthful right there, isn't it? Now here's the simplified hookups right here. This is the control terminal board, and here's the power terminal board. There's an auto manual switch input on terminal 5, and you have to jump that to terminal 11, 0 volts. If you don't jump that out, and when you go to run this, there's LEDs on the operator panel. The run LED will go solid, but the stop LED will blink. Now normally what you want this to do, the run LED would come on and the stop LED would go off when you close the forward/stop or reverse/stop switches. So I have to jump this out. Now sometimes you don't have to, which doesn't make any sense to me. There must be a parameter in the drive that sets this. If I go and I see that stop LED blinking when I go to enable it, I automatically know to jump terminal 5 to 11. Now the forward stop and the reverse stop are switched to terminal 11. If you power up your drive and it comes up EF3, an alarm EF3, that means external fault on terminal 3, so I jump out that. If I get that EF3 fault, I jump that to terminal 11. And in this case, in this drive, I had to do all that. Down here is the speed reference. You increase or decrease the voltage on terminal 16 and the motor will run faster or slower. The wiper of the speed pot, the potentiometer here, goes to 16, and the wings of the potentiometer go to 15 and 17. Over here's the dangerous part. Don't get a hold of that. This is where you want to be especially careful. On this drive, L1, L2, and L3, that's your line voltage in. It's 3-phase, and on this drive, it's 220 volts AC into the drive. Down here is the motor on the T1, T2, and T3 terminals. The frequency of this drive was from 0 to 202 Hertz. But I don't have a spindle motor, but I did have a 60 Hertz squirrel cage induction motor that we slung off of T1, T2, and T3. To simulate a regenerative braking resistor, normally there will be a resistor out here, a power resistor. But to simulate it, I put 6 each 120 volt AC 100 watt light bulbs. 100 watt light bulbs out here. And they go to the B1 plus terminal to the B2 terminal. The minus terminal is not connected. But it gives you good access to view the voltages, the voltage across the bus capacitors. Well, there you go. Okay, come on. Watch my granddaughter run this drive. She had a lot of fun. Alright. Just remember, folks, stay off of this over here. Don't get a hold of that. That'll hurt you. You get a hold of these voltages on this terminal right here, it'll put you on the other side of the dirt. And we don't want to be going there yet. We're too young. Okay. Let's get to watching the rest of this video. Thank you much for watching, and we'll see you next time. It's pretty neat, isn't it?
What's that thing do? What's this thing do?
That's the control panel. Don't speed it up too fast. Don't go above 60. That's good right there.
Don't go above 6.
60.
Oh, okay. What happens if you go above 60?
Well, this is a spindle drive, but that's not a spindle motor.
Oh.
That's a squirrel cage induction motor.
Oh, so it'll break if you go above 60.
No, it won't break. It just you won't have no
Electricity
you won't have
in
no
it?
torque.
Torque?
Yeah, torque is the rotational force.
Oh, it won't rotate.
Yeah. There'd be too much slip. It'll rotate. You just won't have no torque.
Oh, so it'll be like wiggle.
Yeah. If it was hooked up to a machine, it wouldn't run right.
It won't work properly.
Right, exactly. That's a lot of fun, isn't it?
What does it do?
This drive,
It powers the
it runs
light bulbs?
No, those are simulating the regenerative braking transistor. But what this drive does, it runs a spindle motor, and spindle motors are used for cutting. They'll cut holes and they'll cut furniture to different shapes.
So there would be a blade on that thing, but it would be too dangerous to actually have a blade on that.
Well, it's not really a blade, it's more like a drill bit.
Oh, so it's like a drill.
Yeah.
It's like a gigantic drill.
Yeah, and then they have router bits. Router bits cut the sides of things, and drill bits cut holes.
Oh, okay.
Yeah, and this runs real fast. And that motor right there is only meant to run up to 60 hertz.
Sorry.
That's okay. It's all right. That's a lot of fun, isn't it?
I want to get like. I want to make it get like. I want it to end in 0. There. It ends in a 0.
There you go. That's 6.9 hertz. What that means is that...
Oh, oops. I
Yeah.
went above.
That's okay.
I went above.
Give it some speed there. Here. There you go.
Will it hurt if you were to put your hand on that? I bet it would.
Where at?
On there.
On that motor? I don't touch moving parts. It's dangerous. And I don't touch these parts here either because there's high voltages right there. Pretty neat, huh?
It is.
Did you turn it off?
Oh, yeah.
It's still running? There you go, now it's off.
What is it used for?
This drive,
Yeah.
it's in a furniture factory.
Okay. What are these light bulbs for? I meant.
Oh, these light bulbs?
Yeah.
There's a regenerative braking circuit. Whenever you stop a motor real fast, the energy from the motor
Goes into the light bulbs.
goes back into the drive and the bus voltage goes up. And
Bus
there's a circuit in
voltage?
there. Yeah, that's the DC bus voltage. It's like normally without any without it running, it's around 300 volts DC with a 220 volt line applied. But when you stop a motor real fast, that energy from the motor is fed back into the drive through these wires right here.
Then what happens?
And then the bus voltage goes way up. Well, we have to get rid of that energy,
So you put
that
it in the
extra
light bulb?
energy. Exactly. So you put it into the light bulbs.
Oh.
And it's dissipated into the atmosphere as heat. And it protects the bus capacitors inside the drive.
From it heating up.
Yeah, from too much energy.
What would happen if it had too much energy?
Well, you could blow the bus capacitors apart.
Oh, that would
Yeah.
be bad.
Yeah, that would
Place
be.
would blow up.
Yeah.
Considering how much metal stuff and explosive stuff there is in here.
Yeah. Okay. You want to run it again?
No, fine.
One more time. How fast did you go? 43,
I went like 5.484.
54.
I want to see if the light bulb turns on.
No, they won't. There's not enough.
There's
there's-
not enough energy to do
Yeah. Now, if we had a spindle motor,
it.
and
Would work?
and we were cutting something, it would work.
Oh, okay. What can you
Okay.
use to cut it? What can you cut with it? Like wood?
Yeah, you can cut wood, metal,
Oh,
all
okay.
kinds of things.